We can start by just running through the basic rules of exponents again. The first rule, of course, says if we multiply two numbers that are the same, then we can add the powers. So a to the m times a to the n is a to the m plus n. Please pause here and complete the following before you look at the answers. So we have x to the negative 3 times x to the 5. We add the exponents, so minus 3 plus 5 is of course 2. So this is just going to be x squared, or x to the power 2. Here we multiply the numbers, so 5 times 2 is 10. And for the p's we can add the powers, so it's p to the power of 7. Once again here we can multiply the numbers, so 3 times 2 is 6. We add the powers of the a's, so a to the 1 times a squared is a cubed, and b squared times b to the 1. Adding the powers, we get b cubed. So 2 to the 3 times 2 to the negative 1. 3 plus negative 1 is 3 minus 1, which is 2. So it's 2 squared. Then we have 2 plus negative 1 is 2 minus 1, which is 1. So it's just x to the 1 or x. And we have y to the negative 1 times y cubed. Negative 1 plus 3, of course, is 2. So it's y squared. And here we can simplify further. 2 squared is 4. So it's 4x y squared. We can now go to the second rule. We know that when we divide two numbers that are the same, we subtract the powers. So if the bases are the same and we're dividing, then we subtract the powers or the exponents. A to the m divided by a to the n is a to the m minus n. Once again, just pause here and try this quick exercise before looking at the answers. So x to the 4 divided by x squared, we subtract the powers, so 4 minus 2 is 2, so it's just x squared. Here we're going to get a squared, so a to the 2 minus 3. And we know that a minus times a minus is a plus, so it's a to the 2 plus 3. And this is a to the 5. Then we have p to the negative 1 divided by p to the negative 4. So it's p to the negative 1 minus 4. And this is p to the negative 1. A minus times a minus is a plus, so it's minus 1 plus 4. Minus 1 plus 4, of course, is 3. So it's just p cubed. Here the 3 can go into the 9th thrice. And then we have m to the power of 3 minus 2, which is 1, so just m. And the same for the n. 2 minus 1, of course, is 1. So it's just 3 times, or 3mn. We now come to the third rule. When we have brackets, we multiply the powers. So a to the m all to the n is a to the m times n. Once again, just do these quick questions before looking at the answers. So x squared all cubed, we multiply the powers. So it's 2 times 3, which is 6, so it's x to the 6. Here it's important to remember that the power outside the brackets applies to everything inside the brackets. And there's a 1 here that we don't write. So 2 is really 2 to the power 1. So then multiplying the powers, 1 times 2 is 2, and 3 times 2 is 6. And then we know that 2 squared is 4, so it's just 4 times x to the power 6. The same here, we must multiply the power of 5 also with 2. So it's 5 squared, 1 times 2 is 2, then 3 times 2 is 6, and 4 times 2 is 8. And we know that 5 squared is 25. Then minus 1 times minus 2, we know that a minus times a minus is a plus, so it's 4 squared. Minus 1 times minus 1 is 1. So 4 squared is 16, and our answer then is 16p. Many people will make a mistake here. They will say that a squared plus b squared all squared is equal to the following. Should be a square here. They'll apply the square here across the plus, so they'll write it as a to the 4 plus b to the 4. Which is very wrong. This is definitely not equal to a to the 4 plus b to the 4. In other words, you can't apply the square outside the brackets across a plus or a minus. We've got to square this out. Now, just remember that a squared, or rather a plus b all squared, is the first term squared, a squared. Then a times b times 2, so 2ab. And we write a plus here. Whatever sign we have here goes with the middle term. And it's always going to be plus b squared. So if you apply it here, then it's going to be a squared all squared. So a to the 4. The sign over here. And we'll go a squared times b squared times 2. So it's 2a squared b squared. And then b squared all squared is b to the 4. We now come to the fourth law, or rule of exponents. And it says that anything raised to the power 0 is 1. So a to the power 0 is 1. Please try these 3 questions before looking at the answers. In the first one, it's important to recognize that the power of 0 here applies to the x only. So this is going to be 5 times x to the 0, and x to the 0 is 1. So it's just going to be 5. In this case, the power here applies to everything inside the brackets. So immediately we can write down that this is 1. And in the same over here. The power of 0 applies to everything inside the brackets. Let's look at the fourth rule. A to the negative m equals 1 over a to the m. In other words, we can make a negative power positive by writing it as 1 over. So try these questions and then look at the answers. In the first one, it's just going to be 1 over x cubed. Then remember that the negative 2 here applies only to the x. So it's going to be 3 times 1 over x squared. Now also note that 3 is 3 over 1. So we need to simplify this further. So multiplying the numerators, 3 times 1 is 3. And 1 times x squared is x squared. So it's going to be 3 over x squared. Here we can first apply the negative 2 to what's inside the brackets, or alternatively, we can go straight to applying this law. Since the negative 2 is outside the brackets, it's going to be 1 over everything inside the brackets. And of course, then the power becomes positive. Now we can apply one of the previous rules, which says we can multiply the powers. Remember, there's a 1 here that we don't write. So it's going to be 5 squared. In other words, 2 times 1 is 2. So 5 squared. Then 3 times 2 is 6. So it's p to the 6. And of course, there's a 1 here with a q that we don't write. So 1 times 2 is 2. So q squared. And then we always simplify as far as we can. 5 squared is 25. P to the 6th q squared. We can do the same kind of thing here by first writing it as 1 over everything, and the power becomes positive. And now we can apply the power inside the brackets by multiplying the powers out. The 4, of course, has a 1 here that we don't write, and the b as well. So 1 times 3 is 3, so it's 4 cubed. Minus 1 times 3 is minus 3. We can simplify this further. 4 cubed is 4 times 4 times 4, which is 64. The a still has a negative power, so we can actually take it to the top and the power becomes positive. And then of course we have b cubed left. So really, just to show you that if you have, let's say we have x over 2y to the negative 3. The y is in the denominator and it has a negative power, so I can take it to the top and the power becomes positive, and we still have the 2 left. Let's take another example. Let's say I have 5a to the negative 2 over b. Then the a has a negative power, so it can go to the denominator, or into the denominator. It becomes a squared. The power becomes positive, and we still have 5 left on top. Now note that we can only do this if you have a multiplication. If you are multiplying. So I couldn't do it. I couldn't take the y to the top if it was 2 plus or minus y to the negative 3. I couldn't do it. Then just lastly over here, multiplying the powers. Minus 2 times minus 2 is 4. There's a 1 here that we don't write. 1 times negative 2 is negative 2. Negative 2 times negative 2 is 4. Now 3 to the 4 is 81. We still have the r to the 4 on top, and I can take the t to the negative 2 down and it becomes t squared using this principle that we discussed over here. Let's look at the 5th rule. This deals with when we have a fraction raised to a negative power. We simply invert the fraction and the power becomes positive. So a over b to the negative m becomes b over a to the positive m. First try these 3 questions before looking at the answers. In the first one, we can invert the fraction. It becomes y over x to the plus 1, or just y over x. Inverting the fraction here, we get 3m or 3n over 2m, and the power becomes positive. And now we can apply the square to what's inside the brackets. So 3 squared is 9, and we have n squared. 2 squared is 4, and we have m squared. We have a choice here. We could first multiply the powers with the negative 1 outside the brackets, or we can go straight to this rule and first invert the fraction. So let's do that. Of course, this now becomes to the power of plus 1. Now we can use our previous rules of exponents. So 3 squared is 9. I'm also going to bring the 4 to the negative 2 to the top as 4 squared. Then we can subtract the powers of the p's. There's a 1 here that we don't write. So minus 1, of course, is minus 2. And here we have a power of 1 as well. 1 minus minus 3 is 1 plus 3, which is 4. 4 squared is 16, times 9 is 144. And I'm going to take the p to the minus 2 to the denominator as p squared. And on top we are still left with q to the power 4. We now come to the 6th rule of exponents. Here we can write a surd or a root as an exponent by using this rule. The nth root of a to the m is a to the power of m over n. Please do these questions before looking at the answers. In the first one, we can write this as x to the power 2 over 3. In the second question here, we have the square root of 4a. What's important to realize is that both the 4 and the a is under the square root. So the square root applies to both 4 and a. We're going to use prime factors. We're first going to rewrite the 4 in terms of prime factors. We can do that as follows. We take 4 and we take the smallest number that can go into 4 besides 1. So it's 2. 2 into 4 twice. Then the smallest number into 2 is 2. And 2 into 2 once. So we have 4 equals 2 times 2, or 2 squared. So we're first going to write this surd as the square root of 2 squared times a. Now there's a 1 here that we don't write, and a 2 of course here that we don't write. Applying this rule then is going to be 2 to the power 2 over 2. In other words, 2 to the 1 times a to the power 1 over 2. So a to the half. So this is just 2 times a to the power of a half. Here we're first going to write this as an exponent. We're going to divide each of the powers here by the 3 using this rule. Remember, this rule says the mth root, or rather the nth root of a to the m is a to the m over n. So this is simply going to be 2 to the 6 over 3 times p to the 12 over 3 times q to the 3 over 3. And of course this is 2 squared which is 4. And 12 divided by 3 is 4. 3 divided by 3 is 1. Here we're first going to write the 32 as prime factors. The smallest number into 32 is 2, and it goes 16. Into 16, 2, and that goes 8 times. Into 8, 2, and that goes 4 times. We carry on until we get 1. Then 2 into 4 twice. And 2 into 2 once. So we have 1, 2, 3, 4, 5 2's here. So 32 is 2 to the 5. So it's going to be the fifth root of 2 to the 5 times x to the 10 times y to the 15. So we're going to write or divide each of the powers by 5. So it's 2 to the 5 over 5, which is 2 to the 1, which is just 2. Then it's 10 divided by 5 is 2, so it's x squared. 15 divided by 5 is 3, so it's y cubed. A lot of people here will get this wrong. They'll say it's x to the power of 2 over 2, which is 1, so just x, plus y to the power of 2 over 2, so just y. This is definitely very wrong. Once again, we cannot apply this rule across a plus or a minus. So there's nothing we can actually do here, and this just remains the square root of x squared plus y squared. Please try exercise 1 before looking at the answers. In the first one here, we can add the powers. So 4 plus negative 1 is 4 minus 1, which is 3. And 3 cubed, of course, is 27. Here we can subtract the powers. So 4 minus 3 is 1. So it's 2 to the 1, or just 2. Here we multiply the powers. So 2 times 4 is 8. And we can find this on a calculator. Three to the 8 is 6561. Here we can apply the power to both the numerator and the denominator. So it's going to be 3 cubed over 5 cubed, which is 27 over 125. We can write this as 1 over 3 to the 4, which is 1 over 81. We can invert the power here, or rather the fraction here, so it's going to be 4 over 3 to the plus 4. Then 4 to the 4 is 64 over 3 to the 4, which is 81. I think the 64 here is wrong. We can just check what 4 to the 4 is. Two, 5, 6. Then for number 7, we know that anything to the power 0 is 1. And in number 8, we can add the powers. So 2 plus negative 3 is 2 minus 3, which is minus 1. And now we can make the power positive by writing it as 1 over 4 to the 1, or just a quarter. Here we can apply the power outside the brackets to each factor inside the brackets. Remember, there's a 1 here that we don't write. So it's going to be 3 to the 1 times 3 times 2 to the 6th. And that's 27. 3 cubed is 27. 2 to the power 6 is 64. One 728. Here we know that 3 to the 0 is 1. So it's just going to be 5 times 1, which is 5. Everything in the brackets is raised to the power 0. So we know this is going to be 1. Then we have a 2 here that we don't write in the square root. So it's going to be 3 to the 4 over 2, which is 3 squared, which is 9. Once again, there's a 2 here that we don't write. So it's going to be 2 to the power 6 over 2. In other words, 2 cubed. 3 to the power 2 over 2. So just 3 to the 1, which is 3. And then minus 2 over 2, which is minus 1. 2 cubed is 8. Times 3 is 24. And 5 to the minus 1, we can write as 1 over 5. And our answer here comes to 24 over 5. Let's look at number 14. We can first work out inside the brackets. So we know it's going to be 4 to the 2 over 6, which is a third. And 3 to the 4 over 6. Now, 4 over 6 is the same as 2 over 3. This is all cubed. We can multiply the powers. A third times 3 is 1. So it's just 4. And 2/3 times 3 is 2. So it's 3 squared. 3 squared is 9 times 4, of course, is 36. We can subtract the powers of the 2's. So 3 minus 1 here will be 2. And 2 minus minus 1 is 2 plus 1, which is 3. That's going to be 4 times 125. And of course, that's going to be 500. We can apply the square into the brackets by multiplying the powers. 2 times 2 is 4. And minus 1 times 2 is minus 2. Now we can subtract the powers. So 4 minus 1 is 3, so it's 3 cubed. Minus 2, I just want to write this down. Minus 2 minus minus 3 is minus 2 plus 3, which you know is 1. So it's going to be 4 to the power 1. 3 cubed is 27. So it's 27 times 4. Which is 108. Here are a few more questions you should try of exercise 1 before looking at the answers. Let's look at number 17. We can first work out inside the brackets. So that's going to be 5 to the 2 over 3 times 3. Now 4 divided by 3. So 3 to the power of 4 over 3. This of course is all to the power of 6. Then we have 5 times 3 to the 5. Now I can apply the 6, the power here, to the powers inside the brackets, multiplying out the powers. 2/3 times 6. 3 into 6 twice times 2 is 4. 3 into 6 twice times 4 is 8. We can subtract the powers of the 5, or the 5s. So it's going to be 4 minus 1, which is 3. So 5 cubed. And we also have 8 minus 5 is 3. So 3 cubed. This is 125 times 27. And it's 3375. I'm going to do number 18 over here. So we can take the 2 to the negative 3 to the denominator. The power becomes positive. And the 5 to the minus 1 we can take to the top. And it's just 5 to the 1 or 5. And then times 4. So that's 20 over 8. Here I'm going to take the 3 to the minus 2 to the denominator. And it becomes 3 squared. And it's 7 over 3 squared is 9 times 8 is 72. Let's look at the last one. So it's going to be 5 to the 6 over 3. 6 over 3 being 2. So it's 5 squared. Here we're going to multiply the powers. So 2 to the 2 times 2. Or 2 to the 4. And there's a 1 here that we don't write. So 1 times 2 is 2. Then 5 to the 0 is 1. So that's going to give us 25. 2 to the 4 is 16 times 9. So it's 25. 16 times 9 is 144 plus 7. And we can just do this on a calculator. It's 176. Once again, please try this exercise before looking at the answers. In number 1, we're going to multiply out. So 3 times 2 is 6. Then it's a squared times a, which is a cubed. B squared times b, adding the powers, will give us b cubed. In number 2, I'm first going to divide the 5 into the 10. So that's twice. Then we have x squared divided by x cubed. If you subtract the powers, 2 minus 3 of course is minus 1. And for the y's, 3 minus 1 is 2. So it's y squared all over 2. And now we can bring the x to the minus 1 to the denominator. So we're going to get 2 times x to the plus 1. And of course, we still have y squared in the numerator. We're going to multiply the powers. There's a 1 here that we don't write. So 1 times 3 is 3. So we have 5 cubed. And then 2 times 3 is 6. So it's a to the power 6. And then, of course, we have b to the 1 all cubed. So 1 times 3 is 3. And of course, 5 cubed is 125. Looking at number 4, 3 squared is 9. And the power of 0 here applies only to the q. So q to the 0 is 1. And our answer is 9p. Here, everything inside the brackets is to the power 1, or rather 0. So our answer is 1. Multiplying out here, there's a 1 here that we don't write on each of these factors. So it's going to be 5 cubed. Then minus 3 plus 1 for the powers of x is minus 2. And in y times y is y squared, adding the powers. So it's 125. And we're going to take the x to the minus 2 into the denominator as x squared. The power becomes positive. And of course, we still have y squared on top. So there's a power here of 1 with a 4. So 1 times 2 is 2. Then we multiply the powers here. So a to the 2 all squared will be a to the 2 times 2, which is a to the 4. Then we have b squared times c squared. Then 3 squared is 9. And then, of course, a squared. B to the 6, multiplying the powers. 3 times 2 is 6. And then c squared. 4 squared is 16. And in a to the 4 divided by a squared, we subtract the powers. So it's a squared. Then 2 minus 6 is minus 4. And 2 minus 2 is 0. So it's c to the 0, which is just 1. And of course, this is all over 9 still. Then the last step here is to take the b to the minus 4 to the denominator. So it's 16a squared all over 9b to the 4. Here we can first invert the fraction and the power becomes positive. So it becomes to the plus 3. We can now first work inside the brackets. This is p to the 1. So we subtract the powers. 1 minus 3 is minus 2. So it's p to the minus 2, q to the minus 2. We can bring the p down and it becomes p squared as well as the q squared in the denominator. Of course, we still have 2 and then we only have a 5 left on top. Looking at number 9, we know that we're going to divide all the powers by 2 since we are working with a square root. So minus 2 divided by 2 is minus 1. 4 divided by 2 is 2. And 2 divided by 2 is 1. So it's just y. And now we can take the 3 to the negative 1 into the denominator. It becomes 3 to the plus 1. And we still have left x squared y in the numerator. Once again, we can first work inside the brackets here. We're going to divide each power by 6. So it's going to be 2 to the 3 over 6 is a half, 2 to the half. Then 12 divided by 6 is 2. 6 divided by 6 is 1. So it's just y. And this is all squared. Now we can apply the power here and multiply it by each power inside the bracket. So a half times 2 is 1, so it's just 2. Then we have 2 times 2 is 4, so it's x to the 4, y squared. I'm going to continue over here. We subtract the powers of the 2's. So it's going to be 2 to the 1 divided by 2 squared is, of course, 2 to the minus 1. Then we have a 1 here that we don't write. So when we subtract the powers of the x's, it's going to be x cubed and then y. And lastly, we can take the 2 to the negative 1 into the denominator. So it's going to be x cubed y over 2 to the plus 1, or just 2.